going to talk about something a little different and probably take a little bit of a slant on it that is somewhat different. But I was asked to talk about the placenta, and the placenta is something that I've been thinking about for a long time. And so I will give a little story. I hadn't sort of planned on this, but I will give a little story about, I was doing a study 22 years ago, because I can place that, because it was when I was pregnant with my son on fetal growth restriction. It was the fetal growth study at Grady and Northside, which is interesting. There were definitely differences in sort of care at that point when I had my 640 grammar. And I still get emotional about this, which is stupid, so he's fine. But the neonatologist came and said, your placenta is all screwed up. And I said, it's not my placenta, it was his. and I said that because I knew him. I mean, he was a friend, he was a colleague, I'd worked on the study with him, but I also wanted him to say, look, you shouldn't say this to women. It puts guilt on them. But it did start me thinking about this issue of growth and the placenta and how it works together. And so I've been dabbling in this area for a long time. But I have been dabbling. So some of this is sort of recent dabbling, but I do sort of want to put it in that context that this is an area that I've been working in, thinking about for a long time, but not necessarily a deep dive. But the placenta, even though I've been thinking about it for kind of a long time, really has started to come into its own with the Human Placenta Project that NICHD is producing or is working on, because of the idea of the importance of the placenta in fetal development and growth, but that we really haven't had good tools up till now to really look at the placenta during the developmental process. So this is from Guttmacher and Spong in 2015 when they were talking about the Human Placenta Project as a multi-talented but still mysterious organ. And that's because primarily we have been looking at the placenta either in animal models where we can do things to look at the placenta during the developmental process, or only at the end where you can only see what's happened at the end of pregnancy, and you don't know how much, which is chicken and which is egg. So talk about the placenta a little bit. It is as the ultimate multitasker. So it's a time-limited organ which serves the fetus in many, many ways. It nourishes the fetus by providing oxygen and nutrients. So it acts as its lungs, kidney, and liver. It provides immune defense and also functions in an immune way in allowing this foreign invader of the fetus to survive immunologically in the mother. It produces key hormones, and as I said, it modulates the complex immune function. And it is a very beautiful sort of process of intricate programmed vascular growth and invasion and cell death. So adequate placental function is crucial for a healthy pregnancy. Placental insufficiency and size have been associated with a variety of outcomes, including fetal growth and stillbirth, which are what I'll talk about today. But really, in some respects, we don't know how much of this is cause and how much is effect. So how much is the size of the fetus and the health of the fetus driving the size and health and growth of the placenta versus the other way around? So just as sort of a little comment, in the Stillbirth Collaborative Research Network screen, which we talked about last night, we'll talk about more today, almost a quarter of all the stillbirths, the probable or possible cause of death was placental disease. So then I started thinking about thrombophilia and coagulation issues because I was working on a study of von Willebrand disease in women. And for those of you who know about von Willebrand disease, it is a disease like hemophilia, but it's non-sex linked. So women suffer the same degree of bleeding disorder as do men, and therefore women who reproduce have issues related to menstruation because you've got monthly bleeding as well as postpartum hemorrhage. So that really started me thinking about issues related to coagulation disorder during pregnancy. So those of you who know about such things, pregnancy is a state of hypercoagulation. The idea is that you increase the coagulability, I guess is the right term, during pregnancy with the intention of avoiding bleeding during pregnancy as well as bleeding at delivery. So the presence of an inherited thrombophilic polymorphism or mutation may increase risks for thrombosis during pregnancy. Maybe thrombosis sort of systemically, but also potentially, and this is where my thinking started going, in terms of in the placenta leading to reduced placental functioning and efficiency. And so as part of our screen application, this was the proposal that we put in to look at a specific research question was to look at thrombophilic polymorphisms in women and the association with stillbirth. So these markers have been associated with fetal loss. They've been associated with pregnancy complications as well as recurrent fetal loss, pregnancy loss. And so in the Stillbirth Collaborative Research Network, Pinar et al., which in that particular study included both Carol and Barbara, noted that there were placental markers related to bleeding disorders that were associated with stillbirth in this project. So the most common placental findings in stillbirths were inflammatory and thrombotic lesions and retroplacental hematoma. So you can see that if you had evidence of a hematoma in the placenta, you were 7 times more likely to have a stillbirth, and the confidence intervals suggested that this association was pretty high. Maternal thrombus had also a statistically significant increase of about 50% increased risk of stillbirth. The other thing to notice from both of these is, or all 3 of these, is that these are common placental markers both in live births, healthy term pregnancies, as well as in stillbirths. So just the presence of one of these markers or one of these indications does not necessarily lead to a stillbirth, but it does appear to increase the risk. So therefore, we hypothesized that fetal growth would be associated with thrombophilic polymorphisms via a relationship between clotting and placental function, and that this would also increase the risk of stillbirth. And that's specifically what I'm going to talk about more specifically today. So there were 2 research questions that we evaluated that have been published. The first question was, do thrombophilia markers contribute to stillbirth? This was published, the first author on this was Bob Silver in 2016. And the second was, do thrombophilia markers contribute to poor fetal growth among live-born infants? And this was published last year with Alexa Friedman as the first author. So just a reminder, the Stillbirth Collaborative Research Network was an NICHD-funded population-based case control study with cases collected between 2006 and 2008 in 59 hospitals and 4 U.S. counties, including DeKalb County here, and 1 state. Data weights were used to account for differential consent for enrollment, and there was oversampling of preterm live birth and availability of placental examination. So presumably, these data are relatively representative of the general population. So for this analysis, I used logistic regression we used logistic regression to account for the association between stillbirth and thrombophilia markers. We excluded intrapartum stillbirth and those associated with fetal anomalies because presumably placenta and thrombophilia markers would have limited association with those concerns. And then we did a linear regression for association between thrombophilia markers and birth weight for gestational age measured as a percentile. So we looked at thrombophilia markers both in the mom and the blood, the mom and the baby, because obviously they can be different. So we had maternal serum samples and fetal blood samples through either cord blood and or placental tissue. We looked at 5 different thrombophilia markers. Factor V Leiden is a point mutation that is known to affect prothrombin activation, and it increases the risk for deep vein thrombosis by about 2.5 times in the general population. Prothrombin, factor II prothrombin, I have to look here, increases the risk of DVT about 3 to 5-fold in the general population. Pi1 has not been associated with either DVT or stroke in the general population, and the MTHFR mutations have been associated in some studies but inconsistently. So our evidence for association with sort of thrombosis in general is probably strongest for factor V Leiden and prothrombin, and I think that's important as we look at the data. So what did we see? So the first study, as I mentioned, this was a look at thrombophilia markers as its association with stillbirth. And in moms, if the mom had the factor V Leiden, there was about a 2-fold increased risk of stillbirth. And the confidence intervals are relatively imprecise because it's a relatively rare marker. On the other hand, although there was an increased risk point estimate associated with fetal, the marker, the association is very, very imprecise, and so it's hard to gather any real information about that or make any conclusions. The other associations generally are in the positive direction, that there's an increased risk associated with thrombophilia markers, but none of them are precise, and none of them really would lead you to a suggestion that perhaps there's an increased risk of stillbirth associated with the presence of these markers. So taken all together, it's certainly possible that this is present, but it also is possible that this is just due to multiple testing. So then we looked at the same markers in maternal serum and fetal blood related to the birth weight for gestational age. We have a slightly different sample, and so I'm showing the prevalence of these mutations. Again, most of them are relatively rare, at least for factor V Leiden and prothrombin. Pi1 and the MTHFR are more common. So what did we find? Again, we found, and this was in the live birth controls, again we find that factor V Leiden is associated with smaller birth weight for gestational age, but only if it's the maternal marker as compared to the fetal marker, and the rest of the data are null. So although the numbers are relatively small and the estimates are imprecise, they are consistent with what we saw before, even in a different question and a different sample. So in summary, we have obviously some strengths and limitations. Strengths are relative to other studies of this type. We have a large sample size. We have a diverse sampling, a diverse population with estimates that are adjusted to represent the general population. Even though there were multiple sites, there was a standardized protocol for sample collection and placental examination. And we did adjust for response rates. However, we really suffer, even in this relatively large study, from the low prevalence of these mutations, particularly factor V Leiden, which appears to be of the most interest. And our birth weight, the only way we could look at sort of fetal growth issues is to look at birth weight percentile, and that can be an inadequate measure. But in conclusion, we do find some evidence that factor V Leiden may be associated with stillbirth and fetal growth. The extent to which this is related to placental findings, I think, is next to be examined. And we also need to do further research in populations with a higher prevalence of factor V Leiden to evaluate this association with improved precision. So, thank you.